How's it going? Motor City Miner here, coming at you from the old farm at the office, and this will be my last week here. So as you've been watching, you know, in all my prior videos, we've been moving out. There's really not much left here, but still getting new stuff. So brought my Osprey here. You're probably like, why on earth would you not just bring this to the new place? Well, in all truth, so much stuff has moved and it's all at the new place that, well, it's just a mess there right now, and there's no room to work, and it's a work in progress. So we're gonna set this guy up here just to do a review video and kind of get some initial thoughts on the Osprey E300 here. So this is the unit here. We unboxed it, you know, in a prior video. So everything you'll need is pretty normal for really any rig these days. Especially ASICs, or in this case an ASIC form factor. You know, you'll just need your Ethernet. So I got my Ethernet down there running from one of my few switches left in this building, and we do have a power supply. You can either use, you know, like a server power supply with a breakout board, or in my case I'm using an ATX power supply, an EVGA specifically. This is a 1600 watt unit that I had just sitting around here, so that's what we're going to go with. But either way, you'll need something that can output at least 7 to 6 pins. So you got 2 for each board, and then 1 for the control board. So like I said, this is the control board up here. This does just slide out. I'm not going to slide it out just because it's kind of a pain, but if it does need to be replaced, this whole unit does come out. But the more interesting thing, or the thing I'm more interested in, is these FPGA boards. So we're gonna take a deeper look at these. So we're gonna have to take off these fans to do that. All right, so we got our fans off, and a couple things that I noticed while doing this is, actually, usually on an ASIC unit, again this is FPGA, but an ASIC form factor. Normally your Ethernet and this control panel tends to be on the front of the unit, but they actually have the fans essentially sucking in this side and exhausting out this side. So if you're putting this on a rack, you're going to want to make sure the airflow is going this way. I assume it has something to do with where the chips are on the actual boards in here. I'm going to hypothesize that the chip is probably closer to this end where the power comes in. So you want that air to get there as soon as possible. And then this is these are the ends of the heat sinks here, these massive heat sinks. So we'll push these out and take a look at these boards. It is kind of interesting that they have 2 thicker boards and then 1 thinner board. I have reading up online and everything. Apparently this board tends to run a little hotter because its heat sink isn't quite as big. It's also like jammed up against the side here, so it probably has worse airflow too. So it's kind of an interesting design choice. I don't know if it's I would have preferred them all to be the same, to be honest. I don't know if there was not a way to like make the box wider, or you know, whatnot. It just seems really weird to me that, you know, you'd have 2 that are one size and 1 that's the other. I would have liked to see all 3 be the exact same, so it's interchangeable. Especially since this unit is supposed to be buildable, essentially. Like, you can buy just the shell on their website, which I'll kind of show you on their website. It's pretty cool. Essentially, it's like a Lego set, you know. You can buy what you want to get into the FPGA game, because FPGAs are expensive. Realistically speaking, FPGAs are always a ton of money. Even when there was nothing worth mining with an FPGA, like a C 1100, I think the lowest I ever saw them go for was like $950, which is still a lot of money. So like, realistically, this is not a bad deal. A C 1100 does about the same as what comes with these. These boards come with VU 35Ps. In this model, they do have a cheaper model that they just released that has VU 33Ps. So that's kind of interesting, again, kind of pulling down that price point so that people can get into the FPGA game. So I do really appreciate that, and maybe we can get one of those units in the future. I do want to get a few more FPGAs over time, just to, you know, diversify and have more options coin-wise. you can buy, like I said, just the shell, and then you can buy the individual boards. We'll go over that on the website later, but again, that's why I find it kind of weird that they aren't all the same, or they didn't find a way to make it so they can be all the same, because you have to pay attention to, you know, what size boards you already have for the shell or whatnot. But again, super cool that you can buy just one board at a time and slowly expand your FPGA unit. Other thing I noticed is they have this end plate on here, because I thought these would just slide out, but this end plate prevents these from sliding out, so we're going to take that off next, and then we'll get these out to take a closer look at them. Alright, so we got that back plate off, so now these should just slide out. You can kind of see that there's a track that each of the individual boards goes into, and you can clearly see the difference in size here. This one's considerably narrower than the other two. There's a pretty large gap on this side too, so I really don't understand the design decision here to not shift all these, you know, one way. There might have been a conflict with these, but I just feel like there was a way to make these all be the same. So we're gonna slide these out now. You can see I took the data cables off, so we're gonna just slide this out carefully here. It slides out pretty easily. I just having a hard time just because I'm doing this one-handed and don't want to accidentally drop it. So this is a monster heatsink. Holy cow! And this is the smaller one. All right, so that's the board. It's pretty hefty, pretty heavy, for sure. This is the back side. So let's see what we got going on here. All right, so on the back of the board, you can see the copper heatsink pipes that bring out to all those heat sinks. And then this is the back side, so we can't actually see the chip. But this is, you know, your FPGA. And then you can see this is an update they just did. They added all these little heat sinks to the memory units here. Looks like one's a little loose. Well, we'll just have to try it without it today. I'll just take this off before it falls off. But they added these heat sinks on these just so you can actually put more throughput and get even more hash rate apparently. So pretty cool there. That's the one board. We can see what the bigger boards are, but I assume they're going to be about the same. So here, let's slide out. Wow, this is a lot heavier. Holy cow. That extra 7 millimeters of heatsink definitely adds some heft. So let's see. This is the larger one. Like I said, I think this is 27 millimeters and this is only 20. I might be off by a tiny bit on those numbers, but that's what we got. So you can see again, same exact control board though. Really cool watching the videos of how they actually mount these to these custom boards that they've made for the FPGA chip. Cost-wise, like, it's really not too crazy. This chip is on par with a C1100, and realistically, I think if you buy each of these individually on their website, there's a slight upcharge rather than buying it as one cumulative thing. But right now it's under $2,000 for any board, which is cheaper than a C1100. So, you know, you never know what's going to go on with FPGAs or mining hardware in general. You know, especially once Caspa here is fully taken over by ASICs, FPGAs might go down in price, but you know, there's also more bit streams on the way for things like Radiant and maybe Nexa down the line and whatnot. So, you know, if you're buying one of these to mine Caspa, it's probably not worth your while at this point. It's very expensive, but you know, just to get into FPGAs, I think it's a pretty approachable way so far. I mean, I really like the product. I haven't even turned it on yet, so we'll see how it goes once I turn it on. And yeah, well, I'm gonna put this back together and then we will hop into the computer. Alright, so we got it back together, all the boards back in, fans back on, and all our 6 pins plugged in, all 7 of them from our EVGA 1600 watt ATX power supply over there. We do have that short circuited so that it turns on. So I guess we will boot it up here and then we'll have to jump over to the computer, but we'll see what happens when we boot it up. Alright, so it's on, not too loud yet. We'll see how loud it does get. Hopefully not too bad. But yeah, oh, and now it's turned down. So yeah, all back together, turned on. Just have to get some glue to reapply. It's one heat sink. These aren't mandatory, these were added if you're gonna go into like the super high powered mode that they've added, that I believe gets up to like 17.5 gigahash on Caspa now. So we'll just, you know, refrain from going that high for now. We'll use the lower settings until I get this glued back on there. I'm guessing it might have just come loose in shipping or something like that. These are something that they actually applied after the fact. They make these overseas, and then they applied these at their facility in Texas because a new firmware update is what has unlocked this extra power. Maybe in the future these will come directly on them and not glued on after the fact, so that might help with this, but I'm guessing it was just a shipping issue, you know. FedEx is not too kind to things. So we're going to jump over onto the computer and see what's going on there. Alright, so we're on our computer here now, and I've already gone into my router and found out the IP for my Osprey E300. So we logged in there, just the typical, you know, ASIC. If you're familiar with ASICs and whatnot, it's usually something like root or admin and password, and this one follows that same idea, just root and then the password is password. That's all in the instruction booklet. The instruction booklet, like I said prior in the unboxing video, really nice, pretty straightforward. So yeah, so we're in to the GUI here, and you can kind of see there's all these tabs on the left, and then on the right is where the information is. So we'll start in this first tab, which is just the status and settings. So this has all your FPGAs, and then just their current status, and then there's fan information and fan. So right now we're running at apparently 6, and that's 60%. Voltage settings, see a drop down here, so you can actually go card by card, or you can apply the setting to all of them the same. And that is both for your VCC INT and your VCC HBM. Caspa doesn't really use HBM memory, but if you were to buy an ETH hash, you'd want to change that voltage there. And then there's the maximum temperature settings. So you can set that for each FPGA or all at the same. Fan speed adjustments, pretty straightforward. You know, there's auto mode, which is what we're currently in, which uses the fan curve below. This is just the default fan curve. Jumping into the miner page, you can see you have a drop down here where you can select between the two built-in miners, Team Red Miner and All Father. Right now we're stopped. Configuration method. So this is interesting. You can select between either the menu, which is what we currently have, or command line, if you'd want to run it more like a batch file or like you would directly in Linux. I'm going to stick to the menu, just more comfortable with that. It had been a while since I've had to run commands old school way. Algo, you can currently select between Caspa or etc hash. Supposedly Radiant and maybe Ironfish and Nexa are on the way. Pool, you'd enter the pool. Wallet, enter your wallet. Worker ID, default is E300 Osprey. We'll leave it at that for now. And then FPGA core clock and HBM memory clock are where you'd input here below. Alright, and then jumping into update firmware. This is automatically updating. Currently, that's just the default setting. And then system settings is where you can find all your typical IP connection settings, things like that. So yeah, that's kind of it for now. We're gonna kind of get this set up here with that one memory module. I think it's a memory module, I'm not 100% sure, but with that one heatsink off of that one module, I'm just going to use, in the instruction manual, it has a couple different recommended settings. I'm just going to use the low setting right now, which actually will probably be the most efficient, but also the least hash rate. So we're going to use that. So it recommends putting a 600 millivolt for the VCC INT. So we'll put 600. And Caspa doesn't use HBM, so we'll just leave that blank. So we'll press change voltage here, and we get this confirmation that worked. So it says in 20 seconds it will be synced. So we'll see that. Also for maximum temperature, I personally don't like running anything past 80, so we'll just press 80 and apply temperature. And it says that will also be synced in 20 seconds. So that should all update here at the top. These might already be those values. So we got the 600 here and maximum temp of 80. So now we'll hop over to the miner again. All right, so in the miner, selected Team Red Miner. Continuing in this menu method, Caspa, you'd input your pool, which I am using Hero Miners, and your wallet, you'd input your own wallet there. Like I said, want to run this on just the lowest settings, just to start, just to see what it can do in the most efficient, and until I get that heatsink re-pasted on. So right now we're looking at doing, in the instruction manual, it says to try 550 on all three, and HBM, I'll just leave it at the default, which is 1100, and we will press start. Should get a notification here at some point that it has accepted the command. There we go. There's our apply configuration done. Press OK. It now says we're running Team Red Miner. That's great. And you can actually go into the miner log, and we can see the miner actually running. So this being an FPGA miner, it will take a couple minutes usually to start up. That is because the bit streams are being applied to each FPGA, essentially programming the FPGA to be able to function how it needs to for the chosen algorithm. So once those bit streams are loaded, it should start hashing, but we're going to see 0 here for the next couple minutes, so we'll jump ahead in the video to when it has started mining. Alright, so it took about 2.5 minutes from when I pressed from when I accepted the configuration, but you can see here where my cursor is that the bitstream has been loaded on all three FPGAs, and we are now getting accepted shares at the pool. So again, it takes a couple minutes to load those bit streams, so just be patient. That is normal function for an FPGA. And you can see we are getting accepted shares at the pool. Let's see, give it another minute here to ramp up and see what these low efficient settings can get us. Alright, so it's been running for a few minutes now, and you can see that we're currently getting a steady 13.14 gigahash. Again, this is in the low power setting. Should be right around 200 to 250 watts. Really cool temperatures, everything like that. But yeah, it's running real steady, pretty low on the errors. It seems like FPGA 0, which is the one with the smaller heatsink, is getting a few more errors and is definitely warmer by a few degrees. which is to be expected since it has that smaller heatsink. Again, just another reason why I wish that it was all the same, but you know, you might have to keep an eye on that FPGA 0 when you are actually playing with overclocks to make sure that that one is not getting too hot compared to the others. And it is nice that you can apply different overclocks to the different FPGAs, so it is possible to keep that one cooler while adding more power to the others. Alright, so looking through Discord and whatnot, I was curious what the recommendations were, at least for a starting point for this new firmware. Now, again, FPGA 0 is missing that one heatsink, so I'm not going to play around with that one. But I wanted to see what 1 and 2 could maybe accomplish. So we're going to actually use this and just do FPGA 1 to start. They had recommended a starting point of 700, so we'll change that for FPGA 1. Again, you should do this all while your miner has stopped, so I have previously stopped the miner. You can now see that it has updated to that 700 for FPGA 1. I'm also going to do that for FPGA 2, so we'll type in FPGA 2, change voltage. It'll say that'll happen in 20 seconds. We're going to keep our maximum temps the same. You know, like I said, I like 80, you know, just for longevity. It does even recommend that in the GUI here. But that's just what I've typically done for anything, whether it's GPUs, ASICs, or in this case, FPGAs. So this is now updated to 700. So we got our 600 on our FPGA 0, which is the one with the smaller heatsink and harder to cool. And then we have 700 on the 2 larger ones. Alright, and now we're going to go over to the miner to set the core values and get mining at these higher starting points with this updated firmware. Alright, so we put in the new values. We're going to keep the 550 on that FPGA 0 just because it had the smaller heatsink and the missing small little heatsink, but they did recommend 700 for the core clock as well, so 700 on the voltage and 700 on the core. So we're going to press start here and we're going to see what new values we get. Alright, so it's been up and running for a few minutes now on these new settings, and it's been running pretty stably, seeing about the same levels of error on that FPGA 0 on that low power setting, but still nothing to be worried about. It's under 1, as you can see here. But yeah, those other ones now are doing 5.57 each instead of the 4.3, so we've increased our hash rate to 15.5 gigahash total. I think I'm just going to leave it here for now and see how warm it gets. You can see the temperature difference, but again, those bigger heat sinks are really doing well. It's really that one FPGA 0 that just seems to be a little bit hotter, but you know, that's to be expected. So we'll just leave it on these settings for now. I do want to go onto their website just to quickly talk about this whole like build your own FPGA shell option, which I think is a really cool way to get into the FPGA game. So I will bring that up and we'll continue with that discussion here in a moment. Alright, so we're at the official Osprey Electronics store here. Again, I'm not sponsored by them. They did not send me this unit. I purchased this on my own. But, you know, I, having no experience with FPGAs prior, really liked their platform, and I think it's very approachable for a beginner. So this is their current offerings. You can see the E300 here, advertised at 14 gigahash, which includes the VU35P FPGA chip. There is also an E100 VU35P 4.6 gigahash that comes with one hash board in the center there. And then there's a new E300 VU33P, so the slower chip, but all three boards together get you about 8.8 gigahash. I am curious if it what the efficiency on the VU33Ps versus the VU35Ps are. But yeah, it does get a lower price point, which again is great. Even honestly, the E100 is a great deal in my mind. Not financial advice either, but because the C1100, right now it retails for over $2,000. So you get a shell that you can then slowly add more to over time. And how do you go about that? So if you go into the E300s, you can't. But in this E100, if you go into the actual listing, you can actually select different things in here. So you can choose your E100, or instead of getting an E100, which is the shell, you can select different boards. So you can select a VU35P board with a heatsink that's 27.6 millimeters, or the VU35P board plus heatsinks with 20 millimeters. And you can see the different prices here. Now, as I said, this is significantly less than the current price of a C1100. So it really is a great deal to get equivalent performance for a board at this current state. Again, the prices will fluctuate as things become profitable or not, but FPGAs are never cheap. So at least there's this way to get in at a lower price point and slowly over time build up your rig. Going back to the main store page, you can also see that there are options for other fans. If you want the Noctua instead of the loud fans, probably much better for home mining. And then this VU33P is a new offering, so I'm not super familiar with what's in here. It looks like this is going to be shipped out end of May, but again, it just helps people get into FPGA at a lower price than the complete E300. So I really like what they're doing here. It's a essentially it's a chassis platform that you can really just build out. And to even bring that further, they offer reball services for different chips that people may or may not have already. So you can see if you have a VU9P or a VU13P, they actually, you would ship it into them, and for $450 they will add it to their custom board, and then that heatsink, and then you can put that into a shell, because they do in fact sell just a shell by itself for $210, which has 3 slots, and I'm assuming in the reball services that you can, okay, so you can't specify what size heatsink you want, but I'm sure that in the Let's Chat or something, you can make a note to them of what size, say if you were sending a couple different boards. So again, really cool that it's just kind of like an FPGA platform that Osprey is trying to create here, so that you can really get into it at a lower price point and slowly build up your inventory for mining with different FPGAs. It's really trying to make FPGAs more accessible, and that's been, one of the frustrations of FPGAs in the past is the inaccessibility. So really cool option here. I'm enjoying it so far. I definitely plan on getting more over time. So I really commend what they are doing here, and I'm looking forward to getting some more bit streams here in the future. And once we get those, I'll do a follow-up and kind of see what I'm getting hash rates on those. So we're gonna hop back out of the computer here in a moment and do like some final thoughts on the machine. Alright, so I turned off the machine just so you can hear me a little more clear. But just final thoughts on this thing. I mean, it's just a really cool, idea. And makes FPGAs a little more accessible to the average home miner, or even a slightly larger miner like myself. I mean, FPGAs are just historically so expensive, and even if you were able to get them, you know, operating them is very different than what you're typically used to with either an ASIC or GPUs. So really like the idea of just kind of this plug and play shell that you can, you know, expand and buy more boards over time if needed. Again, I'm really excited to get some new bit streams on this in the near future, especially Radiant. That's the one I've really been looking forward to. Caspa's pretty much going the way of the ASIC at this point, so I didn't really get this for Caspa mining. Definitely will mine Caspa on it while I can, but really looking forward to Radiant. I know I hear rumblings of Nexa and also Lithium and Ironfish, but Radiant's kind of the one I'm eyeing, not financial advice. That's just the one I'm excited to try on this machine, and hopefully soon. But yeah, just overall, really impressed. It's definitely cool to have a American, you know, manufacturer, supplier available for an FPGA, and I'm really hoping it makes FPGAs more accessible to the average miner, and we can grow the FPGA mining community. Like I said, it's a really cool way to be able to keep mining things that maybe you didn't quite either find soon enough, or you know, didn't quite get to the bag size you wanted prior to GPU mining becoming really not appropriate anymore for whatever coin you're mining. Do got my little heatsink here still, so I'll definitely get this back on there. But yeah, overall, really happy with this. I'm excited to have this in my mining operations as another machine to diversify. So we'll get it over to the new place here in the next week, because I got to be out of here by the end of the month. But yeah, it's really cool FPGA machine if you are in the market. Yeah, so that's about it for today. Have any questions, comments about this machine, anything you'd like to see me try with it, you know, comment down below, like, subscribe, and yeah, until next time.